Okay, so we have talked about the sourcing. We've also talked about the domain and the basic flip parameters. So now let's take care of the collisions. And although we already have this geometry, I will try to optimize the size of the collider to the size of the domain. So we don't need more than the domain size to create this collider. One of the things that can slow down a flip simulation is your collision object. So I will use this same cube that we created here for our domain. Let's call this domain bounds. And one thing that we can do is boolean this terrain with this box. So I'm going to create an object merge. Let's call this node merge terrain. I will also change its color and jump back to the object context, dive into the terrain geometry, and I will copy this output node, go back to my waterfall, and here under the merge terrain node, paste this path and press enter. So again, I will turn off the rest of the objects. I don't want to see the terrain anymore. Okay, so now I will lay down a Boolean node, connect the terrain to the first input, and my domain bounds to the second input. And change the operation type to intersection. And this time I will create a collision source node connected under the Boolean node. And we've talked about the collision source on previous courses, but just as a refresher, the collision source will create a volume, an SDF called collision, and it will also keep the geometry. If the geometry is moving, it will attempt to generate velocities. In this case, the geometry is static, so we don't really need those velocities. And under the volume tab, you can change the resolution of this collision VDV. And what I usually like to do is connect two nulls, one for my geometry. So I will call this out collision geo. I will copy this node, connect it to the second output, and call it out collision volume. So I may increase the resolution later, but for now let's just use the default. Now I will copy the first node, the collision geo output, dive back into my waterfall top, and if you remember, we created here a merge node. So I will add a static object node. So this node is to create static collisions. I will name it terrain and connect it to the merge node. Now, one important thing, you usually want this static geometry to be on the left side or in the first input of the merge. So you can click here on this up pointing arrow to switch sides. So notice how the left input is affecting the right input. This is why I'm switching the order. And finally, I'm going to link the bounds of my domain to the box that we created in subs. So jump back out. And I will first channel reference the size of this box. So right click on size, copy the parameter, go back to the solver, and paste those values as a relative reference. Now I'll go back, select the center parameter of the cube, so copy the parameter, and back in my solver, paste it as a relative reference for the box center. So now whatever I'm looking at in subs will be the bounds of the simulation. So let's take a look. Okay, so we need to link our output of the collision source to our static node. So again, copy this node, dive back in, and under the static object, look for the sub path, and you can paste the path that you just copied. So if you noticed, I've been going back and forth from subs to dubs. So to make these transitions faster, I like to create bookmarks. So you can control and click number 3 to create one bookmark. Then go back to subs and press Control 2. And the number is more or less arbitrary. You can use from 1 to 5, I believe, to create your bookmarks. But once the bookmarks are created, you can just press 2 and 3 to jump from one marker to the other. So now that that's set, and back to my static object, I will make sure that the type of collision is a volume sample. So remember, I'm outputting an SDF. This I will copy and paste under the proxy volume. Press enter. And once you've done this, you can even turn off the display geometry and then turn on the collision guide. And here you will notice that the resolution of this collision object will be dependent on the resolution of your SDF. So for example, if I bring down the voxel size, increasing the resolution, we will have a much more detailed collision mesh.